Metallurgy. In this lesson, we shall learn about metallurgy and the process of obtaining pure metal from ore. The process used for extraction of metals in their pure form from their ores is referred to as metallurgy. Pure metals can be obtained from their ores through 5 steps. The first step of metallurgy is crushing and grinding of ores. Ores are crushed into a fine powder in big jaw crushers and ball mills. This process is called pulverization. After pulverization, the ores are concentrated based on the type of impurities and their percentage proportions. Removal of impurities results in concentration of the ores. Concentration can be done by any of the 3 methods. Centrifugation is done when there is difference between the densities of the ore and the impurities. In this method, fine powder of ore is placed on a moving table with slots and is moved rapidly such that the particles of metal remain in the slot because of centrifugal force. The dense ore particles settle down in the grooves while the lighter impurities are separated. Froth flotation is used to concentrate ores that are in sulfide forms. Concentration of sulfide ores of copper, lead, and zinc metal are carried out by this method. The ore is taken in a large tank containing oil and water and is agitated with a current of compressed air. The ore, wetted by the oil, separates from the impurities or gangue in the form of froth. Heavy particles like clay, sand, etc. become wet and settle at the bottom. Hence, the sulfide ore is removed with sieves in a second vessel and washed with water. In magnetic separation, the pulverized ore is placed on a conveyor belt that has 2 magnetic wheels. The magnetic particles are attracted to the magnetic wheel and fall separately apart from the non-magnetic particles. Methods like roasting, calcination, and smelting are used to convert the concentrated ore into metal oxide. Roasting is the process of heating the concentrated ore to high temperature in presence of excess air. Calcination is the process of heating the concentrated ore in absence of air at a temperature not sufficient to melt the ore. Smelting is a melting operation in which the constituents of the ore are in melted form. Next step of metallurgy involves reduction of metals. It can be done using reducing agents as well as by the process of electrolysis and thermal decomposition. Reducing agents like carbon or carbon monoxide are used to reduce zinc, iron, lead, and copper oxides. When oxides of metals like iron, manganese and chromium are heated with aluminium, the corresponding metal is obtained by reduction. Electrochemical reduction method is used to obtain metals from oxides of active metals because these metals attract more oxygen than carbon. The metals produced by reduction still contain impurities. Further refining of metals can be done by electrolysis, liquefaction, and distillation. Metals like copper, zinc, tin, lead, chromium, nickel, silver and gold are refined electrolytically. For refining of an impure metal by electrolysis, a thick block of impure metal is made the anode and a thin strip of pure metal is made the cathode. A water-soluble salt is taken as electrolyte. On passing current through the electrolyte, the impure metal from anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. The soluble impurity goes into the solution, whereas the insoluble impurities settle down at the bottom of the anode and is known as the anode mud. This method is used for refining of metals like tin, lead, etc., having low melting points. In this method, a furnace having slope is kept slightly at higher temperature than the melting point of the metal. The metal melts and is collected in the vessel kept below. The melting points of impurities are higher and so do not melt and are found in the solid form on the slope. If impurities are present in traces, the principle of fractional crystallization is followed. The refining of semi-metals like silicon, boron, etc. is carried out by zone refining method. The impurities are more soluble in the molten form. So as the molten metal cools down, the solubility of impurities decreases and separates out from the metal in the form of crystals.